Yes, how many students are coming? Anybody have any idea? Hello, somebody open their mic and tell me how many students are coming. Somebody open their mic and tell me. Without your response, how I can know? And it is a doubt solving session, so you must speak. What are the stuff that is not known to you? What are the things that you want to need to revise? What sort of video lectures will not give you the idea? Everyone, please tell me. So what is your actual doubts in this DCN subject? Tell me first. I think that link and all the video lectures, that teaching scheme and all the stuff that already I have explained you during the regular lectures. Is it so? I think everything I have explained you during that regular lecture regarding teaching scheme with D2D students and all the stuff. Is there any doubt in that one or not? Another stuff that I have explained you about our video channel. So this is one of the message I have dropped in your chat box. So this is one link we have, or this is a YouTube channel we have with this name. If you go with that YouTube channel, let me just again showcase to all of you so you can get the idea. Yes, so if you just go with this particular name, BTCE to Live MEFGI, you are having a computer and IT engineering students that recorded video lectures by the faculty. If you go to the playlist, and if you click on the data communication and networking, so total 36 video lectures are there, which includes laboratory session, lecture session, all the stuff on this particular channel. So there are introduction, basic signaling technique, lab introduction, types of signal, sampling theorem, all the things that we have covered so far. Okay, whatever the things we have covered during the lectures, each and every video recorded lecture that already I have uploaded over there. So you can go to that YouTube link, to that playlist, and you can see all the details from this video lecture whenever you want to refer. As it is informed to me, this is a doubt solving session we have. So you need to generate a doubt, like what are the doubts you have in your mind. You just tell me so I can proceed with that. Everyone. क्या क्या डाउट है आपके, बोलिए सब लोग. What are the doubts you have? Everyone. You can type it in a chat box also, whatever your doubt, topic of your doubt you have. Start typing in a chat box and one by one we will discuss on that. Everyone, do this exercise please. And if you have not any doubt, all the stuff is clear, so you can also write that all things are clear, no doubts we have. Likewise also the stuff that you can write. Everyone. Isn't compulsory to attend or is just only having the doubt? Like for the D2D student, it is compulsory about that. Why? Because some of the topic, if it is missed, so you can just get it, the stuff. Can you please explain the signal? Okay, ducks, about the signals. That's only the one part, or any other things? Because we have conducted near about the 16 lectures, and under the 16 lecture, it is not possible to directly cover into the 3 lectures. We can summarize the thing, but I will let you know that what are the basic thing we have. So as the ducks has started with the doubt about the signal. So let me just share you the first PPT of this particular doubt solving session, and we will just go with the basic stuff. Okay. So first of all, for all the students, what are the topics we have? Okay, that you can see from the syllabus. But overall, we are having a such type of the chapter. We have those who are new and those who don't know about this stuff. Please pay attention over here so you can get the idea. Okay. So let me just start with the stuff. So we have overall 9 chapters we have. In a first chapter, it is a signal characteristic in which the basic fundamental of signals, their features, their characteristic, there are different type of the signal, their frequency response, analog signal, digital signal, periodic signal, non-periodic signal, bandwidth, data rate, bandwidth data rate limit, noise, impairment. So basic stuff related to the signals it's going to discuss in the first chapter. Second chapter, it is a basic understanding about the data communication, that how data going to transform. So what is a data? What do you mean by information? How the data going to travel from one place to another place, and to travel that, what type of the layer structure we have that all the computer or all the networking devices are going to follow. So that is a layer architecture. Then after it will be like in which manner all the devices are going to connect it. So it will redirect you towards the topology. Like what are the different type of topologies are there? Topology is nothing but in which manner your system is connected. Okay, like bus, tree, mesh, okay, hybrid, ring. So what are the different topologies are there? Then after it is having a concept of networks which will categorize in a three-way, LAN, WAN and MAN. So local area network, wide area network, metropolitan area network. So as the geographical location expand, like where you want to make a communication in one laboratory, in one city, or between country to country. So depend on the area, what type of the networking phenomena are there and how it will classify. This all type of the basic networking fundamental and data communication is going to discuss in that data communication chapter. Third chapter, which is a signaling and encoding technique. Okay, why this is a third chapter we required? Because there are a basic fundamental that you supposed to keep in mind, that whatever the data that we are transmitting from one system to another system, it is having either the electrical signal or it is optical signal. So दो तरह के सिग्नल होते हैं हमारे पास, one is electrical, another is optical. Or if it is a free space, so it is a light fidelity signal, free space optic signal, or electromagnetic waves. So which type of the waves you are transmitting, okay, and your system, your computer, your mobile, whatever your digital devices are there, which is actually working on the language of digital, which is 0101 type of the signals. So how this 01 signal actually going to convert to such electrical signal, optical signal, electromagnetic signal, and which type of the terminology, which type of the technique we need to apply, what are the fundamentals of that, this is going to discuss under the chapter number 3. Like you have a digital signal or you have analog signal, so how those signal going to encode it, and it is travel through the cables or through the free space. So that sort of stuff about the signaling encoding technique, NRZ, RZ, Manchester, biphase Manchester, analog to digital, digital to analog, this all stuff going to covered over there. Fourth, we have a bandwidth utilization, multiplexing and spreading. What is inside of that? The fourth chapter. In the fourth chapter, we have like you are having a limited bandwidth. Let's say you are having a 1 Gbps band you have. Okay, but each and every channel is going to consume 100 Mbps speed. So हर एक section को आप you can say there are हर एक source को 100 Mbps bandwidth चाहिए. So how those number of 100 source, 100 mega Mbps of source, how it will accommodate to 1 Gbps bandwidth, that's considered as a multiplexing technique. And if you're doing it reverse, like your bandwidth is requirement is your input source is 100, but to transmit that signal it required a 500 megahertz bandwidth, that's considered as a spreading. So this two technique, that how efficiently we will save our space and do the maximum data transfer through that limited channel, it's considered as a multiplexing. while spreading is used for giving a data privacy by allocating a higher range of the band. So this two technique, while AFDM, TDM, CDM, this technique is going to explain in that bandwidth utilization. Fifth one, which is a transmission media, which will deal with that. What are the different type of the cabling technique we have? Okay, what are the different type of the cables we have? Fiber optic cable, I can say that free space optics, I can say electromagnetic waves, optical fiber cable, twisted pair cable. So that's under the transmission media. So we have reached up to the transmission media, switching up to the transmission media in our regular lectures. We have reached up to that one, and then onwards 6, 7, 8, 9, which is related to switching system, wireless technology like GSM, satellite communication, mobile communication, Zigbee, Bluetooth, Wi-Fi is all going to communicating under the wireless WAN. While in communication technology, there are another stuff like SONET, optical fiber, their cable based network, or some of the rules related to that, which is going to consider under chapter 8 and chapter 9, that how this. So overall, this overall syllabus is related to that, how a data going to communicate from one place to another place, what are the ground functionality of those communication. This is going to consider, or this is going to be delivered under this particular syllabus. इसमें किसी को doubt है? Any question in that one? Be responsive everyone, please. Yes, no, कुछ बोल सकते हो आप. नहीं doubt है तो no कह सकते हो. ठीक है, चलिए. So I'm considering that one student has given that no. Okay. So coming back to the signal. So मैं यहाँ पे आता हूँ. What is a signal? So you can see this a different recorded lecture also. We will get the idea. But as a first doubt we have, what is a signal? Signal is nothing but it's a way of representing your amplitude, your frequency, and your phase of your information. Like whenever you can say, what do you mean by signal? You can say there is having some entity which is carrying some particular information, or we can say which is carrying some amount of the physical entity, which can be observed by some of the detector or by using some of the receiver system. As you can say, right now I'm speaking with you, right now I'm talking with you. So whatever the signaling technique that I'm using from my mouth, it's an audio signal. So it is having a basic three characteristic, like it is having an amplitude, it is having a phase, and it is having a frequency. So signal can be classified by the three different type of the property: amplitude, phase, and frequency. So whenever you have these three basic parameter, it is further going to be classified into the two way: analog signal and digital signal. So digital signal is more related to it is communicated by the digital system, while analog it is communicated by the analog system. So what is the difference between analog signal and digital signal? Analog signal is simply like it is having a continuous time and continuous amplitude vary. Okay, you can see from this analog signal which is at your left hand side, like whenever you can say what is the amplitude of your signal, you can pick up any point and it is going to random, or it is going to continuously change. So whatever the amplitude at this stage or at this time, it is differ at this time. It is again differ at this time. It is again going to differ at this time. So we can say with respect to time change, your amplitude is also going to be changed. So what is a simple word I have narrated over here? Continuous time, continuous amplitude. That's considered as a property of analog signal. While what is a digital signal? It is a discrete time, discrete signal. Meaning of that, for a certain period of discrete period of time, your amplitude is constant. So you can say with this particular period, amplitude is constant. For this period, your amplitude is 0. For this period, your amplitude is something high. So you can say your amplitude is not changing continuously. It is changing discrete, and it is remain same for a specific period of time. So this is the characteristic of digital. Okay. So what is analog? What is digital? One word: continuous time, continuous value. See TCV. This is the analog. While what is digital signal? DTDV. Discrete time, discrete value. Is it okay? Is it okay? What is basic difference between signal? Now, what sort of the stuff that you need to go into the detail about the signal or into the detail of those signal, or this is just about the signal you want to know? That's hello, that's signals were not clear. So now is it clear what is basic difference, or it is okay with you? Now understood. Okay. Furthermore, with addition to this particular question, let me give you the basic idea on that. In the signal, first of all, signal two section, analog and digital. Under this two section, analog and digital, there are a further two classification is there, periodic and non-periodic. So what is the wording that I'm speaking right now? Everybody listen it carefully. So there are basically four type of the signals we have: periodic analog signal, non-periodic analog signal, periodic digital signal, non-periodic digital signal. So first signal, analog and digital. Further, they both are going to classified under periodic and non-periodic. So can anybody tell me what type of the signal I am considered as a periodic analog signal? Have you seen any periodic analog signal anywhere, anytime, any in your life? Somebody please reply me back. Don't sit ideal. अगर आप discuss करोगे तो मुझे पता चलेगा ज़्यादा. There is one discussion was there on the last lecture about the wireless communication. I am very impressed with that. There are lots of information and I'm happy to share with those guys. So be responsive, please. Hello. Can anybody tell me which type of the signal you are thinking as a periodic or it is non-periodic? Periodic, name itself says analog signal is a periodic, but can you give the example that this signal is periodic, this signal is non-periodic? Periodic name says, let me give you the definition, then you just try to identify. Periodic, it means after a specific duration of time or after a specific period of time, signal is going to be repeated again. Yes, periodic, it means time to time. In another word, we can say like that, after some particular duration, whatever the variable, whatever the changes of that signal you have seen, it is repeated again. It is repeated again. So simple example, yeah, at some time interval, some part it will repeat again. We can say all the parts repeat again. Let's say the sinusoidal wave. If I can say sine wave or cos wave, which is going to be a periodic. So after some, yes, there are the waves, specifically those waves that you can define, like sine wave, cos wave, such type of the wave you can define, and you can see that the signal is going to repeat their frequency again. Whatever the electricity coming to your place, it is a periodic signal. Why? Because it's a 50 hertz free phase analog signal you have. So we can say that whatever the rate of electricity of 230 volt, आपके घर में 230 volt आ रहा है, so you can say in that 230 volt, that signal is going to be repeated again and again at a 50 hertz of frequency. So that is a periodic signal. What is a non-periodic signal is there? Non-periodic signal will say that your signal is not repeated the same pattern as I am right now speaking right now. So that audio sequence or audio signal, it is a non-periodic. Like sometime I can speak loudly, sometime I can speak very calm, sometime it is very high frequency, sometime it is low. So we can say that pitch, frequency, amplitude, phase, all in unpredictable, true breath. So if the signal, their amplitude, their frequency, you cannot predict, or it is not repeated in some pattern, that's considered as a non-periodic signal. So this is the same thing is applicable to both of the side. If you can say there is an analog signal or digital signal, so the signal where you can predict this all the three value, like you can predict their frequency, you can predict their phase, you can predict their amplitude. Frequency, phase and amplitude you can directly predict by looking to that signal. That's considered as a periodic signal. And if you cannot judge that exact frequency of that signal, that's considered as a non-periodic signal, which is a non-predictable. Okay, that is not a single frequency, it is a range of frequencies are there. So there are two basic classification we have, okay, that we have discussed in that signaling chapter. After that signaling chapter, what we have discussed, let me just go with that slide so you will get the idea. So this is the stuff I have discussed: periodic signal, non-periodic signal, and all the stuff. As well as we have discussed about the basic fundamental of time and frequency domain. Like you can say there are two ways of presenting the signal: time domain presentation, frequency domain presentation. So in time domain presentation, you need to showcase your signal which is changing with respect to time. While in frequency domain, the same signal is going to present it with single spike. Okay, so in time domain signal, it is showing that what is amplitude variation, what is the time it will take to complete one cycle, what is the phase of that. So you need to show the such type of the sinusoidal time variation signal is there. While in frequency domain, what you have, there are a single spike line is there which will show you that there are a 5-volt peak is there for that one particular signal. So in general, it is look like this one. There are a time two domain we have. So time, frequency, and amplitude axis. So if you see from this time window, so signal is going to be showing like that. It is changing their shape, or it is just changing their amplitude with respect to time. While in the frequency, it is look like that. What is the particular range of that frequency? The single spike of that amplitude going to show. अगर मैं इसको सिंपल डोमेन में बोलूं तो मैं क्या कह सकता हूं? फ्रीक्वेंसी एक्सिस पे, फ्रीक्वेंसी डोमेन में आपको एक्स एक्सिस पे क्या डिफाइन करना पड़ेगा? फ्रीक्वेंसी. While in time domain, what you need to showcase? You need to showcase the time variation. So सिग्नल की, पीरियोडिक सिग्नल की फ्रीक्वेंसी एक ही होती है. अगर मैं बोलूं आपके घर पे कौन सी फ्रीक्वेंसी का इनपुट सिग्नल मिल रहा है, इलेक्ट्रिसिटी सिग्नल, you can say this is the 50 hertz. So frequency is a 150 hertz. तो एक ही स्पाइक आएगा 50 हर्ट्ज पे फ्रीक्वेंसी डोमेन पे. बट टाइम डोमेन में क्या होगा? It is showing like that how much time it will take to complete the one cycle. So that's why such type of the time variation is there, amplitude variation is there with respect to time. Have you guys got this stuff, or basic difference between time domain and frequency domain? हेलो, ओके, चलो, अच्छा है, बढ़िया सब लोग. So then after it is discussed about the what is a presentation like composite signal we have. If there are a multiple sinusoidal wave combined together, इस सबका amplitude को combine करके आपको ऐसा composite signal मिलेगा. So if such type of the composite signal you have, from that you can identify there are a specific range of the frequency associated with that. So आप ऐसा कह सकते हो ये composite signal है वो 3 frequency से generate होता है. You can say that F, 3F and 9F. If you show them in a discrete manner, it will look like this one, that pink color is for F, blue color is for 3F, black color is for 9F. But if you show the composite signal, it might be look like this one. तो आपको एक ही सिग्नल दिख रहा है लेकिन उसके अंदर 3 फ्रीक्वेंसी कंपोनेंट है. सो यहाँ पे हमारे पास एक डेफिनेशन आती है जिसको बोलते हैं वे ऑफ प्रेजेंटिंग इन अ फ्रीक्वेंसी डोमेन फॉर सच कंपोजिट सिग्नल. कि अगर हमारे पास कोई कंपोजिट सिग्नल है और वो कंपोजिट सिग्नल अलग-अलग पीरियोडिक सिग्नल से बना हुआ है. Remember this stuff in your mind very clearly. You have a composite signal is there, but that composite signal is made up of a different periodic signal. जैसे कि यहाँ पे दिखाया हुआ 3 तरह के सिग्नल इकट्ठा होकर ऐसा सिग्नल बना रहा है. So we can say your all the 3 signal are going to periodic and combinedly it is creating some composite signal. तो उसका frequency domain कैसा होगा? जो भी frequency वो composition में participate कर रही है, whatever the signal is participating in that composition, you need to show their amplitude and their discrete stick or we can say discrete spike of at specific frequency. तो ये टाइम डोमेन सिग्नल के लिए उसका फ्रीक्वेंसी डोमेन कैसा होगा? लाइक दिस वन. सो एनालॉग पीरियोडिक कंपोजिट सिग्नल के लिए हमारा फ्रीक्वेंसी डोमेन डिस्क्रीट फ्रीक्वेंसी से बना होगा. पूरा वो सिग्नल का फ्रीक्वेंसी डोमेन कैसा होगा? इट इंक्लूड द डिस्क्रीट फ्रीक्वेंसी. While in another hand, if you can say there are another type of the signal which is a non-periodic. ये सिग्नल भी composite सिग्नल है, बहुत सारी फ्रीक्वेंसी से बना हुआ है. There are a mixture of frequency, but those all frequency are non-periodic. कौन सी फ्रीक्वेंसी, कौन सा एम्पलीट्यूड, कौन सा फेज, कुछ पता नहीं है. It is a look like such a random signal. So the analog non-periodic signal create a continuous frequency domain. क्यों continuous बनेगा? क्योंकि आप इसमें से कोई फ्रीक्वेंसी प्रिडिक्ट कर ही नहीं सकते हो कि वो ये कौन सी फ्रीक्वेंसी से बनेगा. So it is not contain a single frequency, it is containing an entire band. क्या आप ऐसा पता कर सकते हो कि ये पूरे सिस्टम में मिनिमम फ्रीक्वेंसी ये है, मैक्सिमम फ्रीक्वेंसी ये है, और जैसे आप मिनिमम टू मैक्सिमम फ्रीक्वेंसी का बटन आप घुमाते जाओगे, it will give you some amplitude. So you can predict their continuous band, not a discrete band. तो क्या यहाँ पे डेफिनेशन हुई? एनालॉग सिग्नल है, कंटिन्यूअस है, और कंपोजिशन आप कर रहे हो ऐसे सिग्नल का. एनालॉग पीरियोडिक सिग्नल का कंपोजिशन करने से आपको फ्रीक्वेंसी डोमेन डिस्क्रीट मिलेगा. While एनालॉग नॉन पीरियोडिक सिग्नल का आप कंपोजिशन करोगे तो आपका फ्रीक्वेंसी डोमेन कंटिन्यूअस मिलेगा. These are the basic stuff between bandwidth of that, and this thing, same thing is applicable to both of them. So you can say there is a same signal. This is the periodic signal bandwidth. How it will look like? There are different spikes of that particular frequency spectrum. While in a non-periodic signal, it is a continuous band. अगर आपका सिग्नल पीरियोडिक है तो ऐसा बैंड बनेगा, अगर नॉन पीरियोडिक है तो ये ऐसा बैंड बनेगा. And the same thing which is applicable for digital signal also. Whenever you say digital signal periodic, signal is going to discrete. Digital signal non-periodic, एक ही spike है, बाद में zero है. So the signal is become continuous. Frequency domain is become the continuous for that. Any doubt in this one so far? Anybody? Please tell me अगर आपको कोई डाउट है यहाँ पे, चलिए बताइए. If you have any doubt, any question, please ask me. चलिए ठीक है. Any other doubt? चलिए यहाँ तक तो हम आगे. Bandwidth with example. Okay. Explain a bandwidth with example. चलिए मैं आपको बताता हूँ कि let me tell you, let me just do a one task over here. So it is a अरे सब लोग सुनिएगा, ठीक है? जस्ट अ सेकेंड, गिव मी अ मिनट प्लीज. Okay, sorry for the delay. Let me just show you. Let me just everybody just open their speaker and listen this one. Okay, is everyone can hear the tone? No, just a second, huh? Hello, am I audible? Hello, now? Am I audible now? Hello? Okay, chaliye. So what I'm saying, I have shared you the one particular link. Everybody just go to that link and see that which type of the signal you are observing, analog, digital, periodic, non-periodic. Then I will give you the answer of that bandwidth. First, let everybody tell me. Have you guys heard it? कौन सा सिग्नल है वो? पीरियोडिक है, नॉन पीरियोडिक है? It is periodic or non-periodic? Sine is a periodic. Okay. Second thing, everyone. Second thing, let me just tell you. Go to this link, everyone, and click on the play button. And remember, what is the maximum frequency you can hear? ये लिंक पे जाइए, उसको प्ले करिए, और जो भी नंबर वहां पे दिखाई दे रहा है वहां पे इन दिस हर्ट्ज बॉक्स, रिमेंबर दैट विच लास्ट हर्ट्ज यू आर एबल टू हियर. आप कौन सी रेंज तक सुन सकते हो, आप उसको ट्राई करिए और यहाँ पे चैट बॉक्स में लिखिए कि सर आई कैन हियर अप टू दिस रेंज, एवरीवन डू दैट. चलो ये लिंक पे जाओ, ये 2 मिनट का टेस्ट है, करो और पता करो आप कौन सी रेंज तक सुन सकते हो. एवरीवन, आई एम वेटिंग द आंसर ऑफ ऑल ऑफ यू. Okay, 16, 9,000 hertz only 9,000 hertz. 2,000 hertz, 16,000 hertz, 13,000, 18,000 hertz. Vivek Satani having a good more than 16. Entire 20,000 hertz. Yasa. Really? Yasa, I think it is not possible. You have directly written a last range of 20,000 hertz. You can hear up to 20,000. Wow. Two students are there. Himani Ben. Himani Ben, open your mic. You're able to hear 20,000 complete range.
Yes, sir.
That's great. Very good ear you have. Very fine vibration of that sound you can hear. Good. I have seen this first time in this batch. Maximum it is go up to 18, 90. It shows 20,000 hertz. It is last range is 20,000 hertz. I am saying that how much you can hear. Okay, whatever it is. So it is around 18, 15, 16, 18, 19. So above the 15 hertz. So we can say what is your range. When we talk about the bandwidth, bandwidth is going to be tell you that what is your starting range and what is your ending range. So bandwidth can be defined as whatever the observation you are doing. Let's say we have done the observation of hearing. So what is your bandwidth? Your bandwidth is ideally which is going to be a 20 hertz to 20 kilohertz. So whenever we run one experiment and we will decide that what is your minimum input and what is your maximum input, that range of those maximum and minimum consider as a bandwidth of that system. Yes, Sawan Kumar, you have raised the hand. Tell me, what's your question? Sawan Kumar? Oh, Sawan Kumar is left. Okay. So that's about the bandwidth. Is it clear? Is it clear with you? Those who have asked me the question on bandwidth. Is it clear with you? What do you mean by bandwidth? Okay. So it's around the range. In which range we are talking about? Yes, next doubt. Signal, bandwidth, any other doubt? Please ask me if you have doubt solving. I prefer that everyone, whatever the link that I am share with you, whatever the link I am share with you over here, see those recorded video lecture. You will get all the stuff. Explain the PFK and that stuff. Wavelength in brief. Okay. Wavelength and FSK, PSK. Madhav, are you talking about that ASK, FSK, PSK? Shift keying, that technique, PFK. Okay, chaliye. So first we will take a question of Dux about the wavelength, and then we will take an example of, then we will go with the doubt of Madhav. Okay. So Dux, wavelength is nothing but it is the ratio of speed of light with respect to that what is your frequency and what is your free space speed of light you have. Simply you can say F equal to C by lambda or lambda equal to C by F. That's the first relationship we have. Like if you have a frequency of any particular signal, let's say you can say there are a 20 kilohertz is a audible frequency. So if you have a frequency, so how you can get the wavelength? By taking a ratio of what is the speed of light, which is 3 into 10 raised to 8 meter per second, divided by what is the frequency. By taking this ratio, you can get the wavelength. Another definition of the wavelength is going to be identified by what is the rate of change of speed. We can say how much speed is going to change when a signal entering from one medium to another medium. You can say you are launching a light into the free space and later on that light is going to enter to the water. आप कोई लेजर बीम एमिट कर रहे हो, लेकिन वो लेजर बीम आप कोई वाटर बॉडी के अंदर, कोई पानी के अंदर आप कर रहे हो, तो क्या होगा? Whenever the laser emit, it is in the open space, वो एयर में है. जैसे ही वो लाइट पानी के अंदर एंटर होगी, we can say the wavelength of that particular signal, it is going to change. Now why it is going to change? Due to the property of that material. हर एक मटेरियल की अलग अलग अपनी प्रॉपर्टी होती है. Like depend on that material property, it is affected with permittivity and permeability. If you know your physics 12 physics, at the time there are two parameter we have: permittivity and permeability, magnetic and electric constant. With respect to that, whatever the input signal, whether it is an electrical signal or you can say the light signal you are inserting, signal become either slow down or it is speed up. आपका सिग्नल का स्पीड बढ़ेगा या घटेगा जब वो एक मीडियम से दूसरे मीडियम में एंटर करता है. So the change of this particular speed, it's considered as a wavelength of that particular structure. Okay, कैसे हम पता करेंगे? अगर आप साइनोसोडल वेव को लाइट आपकी साइनोसोडल वेव को लेजर लाइट ही पकड़ लीजिए, तो लेजर लाइट रेड कलर की है तो उसका वेवलेंथ होगा 520 लेट्स से 700 नैनोमीटर. 700 नैनोमीटर का आपका कोई रेड लाइट का सिग्नल है, आप उसको लाइट में इंसर्ट करते हो तो क्या होगा? वो रेड लाइट रहेगी नहीं. It is just expand, it is become a diluted red, or it is something else it's going to happen. If the same white light you are inserting to prism, तो वो white light prism के दूसरे जगह पे नहीं रहती. It is expanded into the entire broad spectrum. वो बोलते हैं ना violet, blue, green, वो पूरा spectrum होता है. It is emitted in this spectrum. So why is it happen? Because whenever your signal entering from one medium to another medium, the speed is going to change. स्पीड चेंज होती है मतलब कि जो एक साइकिल कंप्लीट करने के लिए टाइम लेता होगा वो फ्री स्पेस में, वो टाइम अगर बढ़ जाएगा या घट जाएगा. दैट अमाउंट ऑफ टाइम टू कंप्लीट दैट वन साइकिल इज आइदर इंक्रीज और डिक्रीज. दैट इंक्रीज एंड डिक्रीज यू कैन फाइंड आउट दैट पीरियड एंड इट विल गिव यू द वेवलेंथ ऑफ दैट पर्टिकुलर स्टफ. गेटिंग माय पॉइंट और नॉट, माधव? Sorry, Dux. Yeah, Dux has asked the question. Dux, माइक ओपन करके डिस्कस करिए अगर नहीं आपको ये कन्विंसिंग है तो प्लीज. चलिए ठीक है. नेक्स्ट इट इज अ क्वेश्चन ऑफ माधव about the ASK, FSK and PSK. Let me just open that PPT and just give me a minute, okay? Madam. Okay, chalo. So we will start with that stuff. Let me share the stuff. Just give me a minute, okay? Okay, so this is the screen of that particular. I think it is visible to everyone. So there are three techniques. Now, what is this three technique? First of all, you need to keep that stuff in your mind very clear. That there are four type of the signal conversion technique you have. हमने दो तरह के सिग्नल देखे. कौन से? We have seen two type of the signal, analog and digital. So conversion from analog to digital to analog is possible. So the thing we have, like we are having a four type of the signal conversion technique we have. First, which is the opposite of that side, which is like analog to digital to analog. दो टेक्निक हो गई, analog to digital to analog. So there is a but obvious कि एक तरह के सिग्नल से दूसरी तरह के सिग्नल में वो ट्रांसफॉर्म हो रहा है. Another two type of the signal which is considered as a digital to digital and analog to analog. So when we can say digital to digital technique, which is nothing but like those technique name as a NRZ, RZ, okay, biphase Manchester, उसमें क्या होगा कि आपका इनपुट भी 0101 है और आउटपुट भी डिस्क्रीट टाइम डिस्क्रीट वैल्यू है, डिजिटल वेवफॉर्म है, लेकिन सेम तरह की डिजिटल पैटर्न के लिए आप अलग अलग तरह के डिजिटल सिग्नल आप बना सकते हो। यहाँ पे दो चीज आपको समझनी जरूरी है, डेटा एंड सिग्नल। डिजिटल डेटा इट मींस इट्स अ सिंपल 0101, दैट्स द स्टफ, while what is digital signal, it is a value of amplitude. Amplitude change होता है plus v minus v plus 5 minus 5 but in a discrete manner. तो इनपुट भी आपका 0101 है, आउटपुट आपका डिजिटल सिग्नल है। सर when you converting a same type of the digital data into the different type of the digital signal, नहीं ब्लैंक सिग्नल नहीं है, मैं वो पीपीटी में नहीं दिखा रहा हूं। इज इट नाउ, इज इट ओके नाउ? दक्ष दिख रहा है? Is it now okay? चलिए, so first remember this thing, then I am coming to this ASK, FSK and PSK. तो पहला टाइप का सिग्नल हमारा हुआ डिजिटल टू डिजिटल, कि आपका डेटा भी 01 में है, आउटपुट भी डिस्क्रीट सिग्नल डिस्क्रीट वैल्यू है। दूसरे टाइप का सिग्नल जो भी स्ट्रेट फॉरवर्ड एनालॉग टू एनालॉग। So whenever you are having your input signal is analog as well as your output signal is analog. So what is the difference? Like it is having a technique of AM, FM and PM, amplitude modulation, frequency modulation and phase modulation. इसमें क्या होगा? Your input is a something low signal. Let's say you are having a 2 kilohertz signal, but whenever the output signal generating from that conversion, it is superimposed on high frequency signal. जैसे कि हम रेडियो स्टेशन में करते हैं कि रेडियो स्टेशन में कोई भी जॉकी है और आरजे आर देयर, दे आर स्पीकिंग ऑन 20 किलोहर्ट्ज ओनली, वो 20 किलोहर्ट्ज से ज्यादा नहीं बोल सकता, लेकिन आप रेडियो अलग अलग स्टेशन पे सुन सकते हो 98.3, 92.7, 102. सो दिस 98. It's what is this number? This number is a high frequency signal कि जिसके ऊपर वो 20 हर्ट्ज का सिग्नल सुपर इम्पोज हुआ होगा। So whenever we are doing such thing कि आपका एनालॉग सिग्नल कम फ्रीक्वेंसी वाला, कम एम्पलीट्यूड वाला है, उसको आप सुपर इंपोज करो हाई फ्रीक्वेंसी पे, that's considered as an analog to analog conversion technique. Okay, so this is the analog to analog conversion. What is a third technique, analog to digital? Like आपके पास 0101 है, लेकिन आप आउटपुट क्या कन्वर्जन करते हो? Sorry, you have analog to digital, so you have input as a sinusoidal wave, but you are converting into the digital signal. So उसके लिए हमको हमारे पास क्या टेक्निक है? एनालॉग टू डिजिटल कन्वर्टर, जिसमें वो सैम्पलिंग, क्वांटाइजेशन, एनकोडिंग, दैट ब्लॉक्स आर देयर, as well as delta modulation. So this particular blocks or this circuitry convert from analog to digital. Fourth one, which is this one, which is a digital to analog conversion. What is the inside of the digital to analog conversion? That your input is digital but output is analog. मतलब कि एक साइड पे आपका 0101 होगा और दूसरी साइड पे कुछ साइनोसॉइडल वेव निकलेगा। Okay, so that's considered as a digital to analog. Three technique we have: ASK, FSK, PSK. Why there is a three technique? Because आप एनालॉग सिग्नल के तीन बेसिक पैरामीटर ही चेंज कर सकते हो। Either you will change their amplitude, or you change their frequency, or you change their phase. Now whenever I say to change, तो कैसे चेंज करोगे भाई? You change according to your input signal. और यहाँ पे इनपुट हमारा क्या है? Digital signal input we have. So if I can say the definition of digital to analog conversion, like your analog signal, which is output signal, is changing their value according to the input digital signal you are giving. बट वो वैल्यू कितने टाइम में चेंज करेगा? वो तीन तरह की वैल्यू चेंज कर सकता है कि आप डिजिटल सिग्नल दो और वो अपना एम्पलीट्यूड चेंज करे, तो उसको क्या बोलते हैं? ASK. आप इनपुट सिग्नल 0101 दो, वो अपना फ्रीक्वेंसी चेंज करेगा, इट्स कंसीडर्ड एज FSK. You give the digital signal and it is change its phase, it's considered as a PSK. तो जैसे ही डिजिटल डेटा चेंज होता है, तो आउटपुट में ना एम्पलीट्यूड चेंज होगा, फ्रीक्वेंसी चेंज होगा या फेज चेंज होगा. According to that, it is considered as a ASK, FSK and PSK. When you changing both stuff, two stuff simultaneously, आप उसका एम्पलीट्यूड भी चेंज करो और फेज भी चेंज करो. So hybrid modulation technique is a QAM, quadrature amplitude modulation. But that is later on you can understand. But first, we will go with the ASK, FSK and PSK. So ASK directly we will go with that signal. यहाँ पे आप देख सकते हो, whenever one amplitude is full, अगर आपके पास 5 वोल्ट का साइनसोइडल वेव है और उसकी फ्रीक्वेंसी 10 हर्ट्ज 10 हर्ट्ज है या 10 किलोहर्ट्ज है, so 5 volt 10 kilohertz full signal is there during the period of 1 आ रहा है तो पूरा एम्पलीट्यूड और फ्रीक्वेंसी अच्छे से चलेगी. whenever it is come 0, it is a straight, no signal, no frequency, no amplitude, nothing. So that's the stuff. 1 मतलब कि full signal amplitude is present, 0 it means no amplitude. So ये हुआ ना amplitude change कि 1 के ऊपर amplitude है, 0 के ऊपर कुछ नहीं है. So we can say this is the amplitude shifting signal, कि आपका साइनोसॉइडल वेव जो आउटपुट आप देख रहे हो उसका एम्पलीट्यूड चेंज होगा. कैसे? आप जैसे 1010 पैटर्न दे रहे हो उस हिसाब से. So it will generate like this one. This is your input signal, this is your carrier signal which is an analog signal that you want to change, and this is your output. आप देख सकते हो जहां पे वो 0 है amplitude is 0, whenever 1 amplitude is as it is. That's the ASK. What is FSK? FSK, it will change the frequency. आप देख सकते हो यहाँ पे 1 is there, there are a different signal you have. 0, there are a different signal. और ये भी पता कर सकते हैं, we can know that stuff very easily. Like frequency of this signal is higher, while frequency of this signal is lower. So meaning of that, whenever the frequency is going to change with respect to the, I can say, signal 1 and 0, that's considered as a FSK signal. Over here, high frequency for 1, low frequency for 0. So that's considered as a FSK signal. How FSK signal generated? It is generated from frequent voltage control oscillator. कि जिस हिसाब से आप वोल्टेज इंसर्ट करते जा रहे हो उसका फ्रीक्वेंसी बढ़ेगा या घटेगा. So 1 के लिए फ्रीक्वेंसी ज्यादा जनरेट करेगा, 0 के लिए कम फ्रीक्वेंसी जनरेट करेगा. That is a functionality of voltage control oscillator we have. So that's the characteristic of FSK. While it is change the frequency depend on the beats you are giving. What is PSK? PSK again. Now phase is going to be changed, frequency and amplitude constant. So what you can say, whenever 1 normal signal is there, but whenever 0, you can see this black color signal is totally the phase shifted from previous. ये जो सिग्नल था उसका opposite signal हो गया, यहाँ पे phase उसका change हो गया. Again 1 आया तो original signal is there, again 0, phase going to be changed. So whenever 1 and 0 going to change, your phase of your signal also going to be changed. That's considered as a PSK. एक चीज यहाँ पे हमको ध्यान रखनी पड़ेगी, whenever I can say ASK, FSK और PSK, अगर ASK हो रहा है तो फ्रीक्वेंसी और फेज कांस्टेंट रहेगा. अगर FSK हो रहा है तो फेज और एम्पलीट्यूड कांस्टेंट रहेगा. अगर PSK हो रहा है तो एम्पलीट्यूड और फ्रीक्वेंसी कांस्टेंट रहेगी. These are the basic stuff we have in ASK, FSK and PSK. So how the we can say that PSK going to generated? PSK going to generated by having a two signal. We can say the two-sided polar signal. One with the positive voltage, 0 with the negative voltage. तो क्या होगा? Positive के साथ signal as it is रहेगा. जैसे ही negative signal आएगा, it is inverted to negative. इसका amplitude और इसका amplitude make the signal inverted, and that inverted is nothing but the phase shifted signal. Have you clear with this ASK, FSK and PSK? Ducks? Hello, Ducks. Is it okay?
Sir, it's not ducks, it's mother.
Okay, so who has asked? Ducks has asked or Madhav? Yes, Madhav. Sorry, I forgot name. Madhav, is it okay, Madhav? Madhav is there? हेलो माधव
Yes,
चलिए
sir.
ठीक है कोई बात नहीं so we will keep up to this one and from next lecture we will discuss your rest of the doubt but I prefer before coming to the doubt please see the recorded video lecture and if you have doubt from the recorded video lecture let me know but please see those video recorded lecture as it is uploaded into the that particular link or in that playlist. So everybody write their enrollment number and name and then they can go. We will meet you tomorrow with your doubt and that solution or with their query. Okay? Have a good day everyone. Bye bye. But be ready with the doubt for tomorrow everyone.